All right, let's talk about another issue with arrays, and that is parallel arrays. One problem you have with a regular array, and this is true in most languages, is that you can only store one type of thing in the array, right? So even with two-dimensional arrays, everything in it is numeric or it's a string, right? But I can't mix strings and numerics together in a single array. So let's say if I wanted to store something like I'm keeping track of my inventory. I've got numbers assigned to each item and a name assigned to each item, obviously. And I want to store these in some sort of database table where I can go in and actually modify them. I can't do that. Typically, I can't do that because one thing is going to be a string and one thing is going to be a numeric. So what you do is you create what's known as a parallel array. Which is just something like this. If you want to keep track of, let's say, a part number, right? And I'll say I'm going to keep track of 100 part numbers. And I'm also going to keep track of the part name, right? And I'll have 100 of those. And let's say even I keep track of the part cost. Now, there's nothing that says that every one of these arrays has to start with the same name. In fact, there's really not much of a connection between these arrays at all. And that's part of the hassle with parallel arrays is you got to make sure you remember that if you do something to like element 5 of part number, you also need to do it to element 5 of part name and element 5 of part cost. In other words, if you were like removing one of the parts and you wanted to remove the one at index 5, you got to make sure you do that to all three. Or if you're doing something like putting all the arrays in order, you were like putting them in alphabetical order by their part name. If you move one around, you got to make sure you move the part number and the corresponding part cost with it, right? So there's no strong connection between these three arrays. You just have to do it in the programming, right? And that's kind of a drawback of parallel arrays. But in just about any language, you can create parallel array. If you can create an array, you can create a parallel array. Some languages have slightly better constructions, like some languages have structures, which a structure is something that allows you to store maybe an integer, a string, and a floating point number, like what would be the cost. Store those together in a unit, and then you can create an array of those, which is really a much better way of doing it. But let's say we've got something like this, and I want to set up a loop that's going to allow me to just enter all 100 of them, right? So I'll say something like index equals 0, while index is less than 100. Print enter the part number, right? Input part number sub index. Okay, so when index is 0, the user is going to type in a part number, and that's going to be placed into part number sub 0. And I can print enter the part name. And of course, this is just output, just prompting the user. Okay, so that's all we got to do to get all 100 of those entered. Don't forget to increment index by 1, right? And that's the end of the while loop, okay? To display them back on the screen, kind of the same thing. You can say something like index equals 0 while index is less than 100. Print, whoa, what happened there? Okay, so somehow I clicked on right to left reading order, which I never knew existed before. But anyway, so I can print part number index. And this is not terribly interesting, except again to remind you that the indexed element of part number is associated with the indexed element of part name is associated with the indexed element of part cost. In other words, they belong together, but they're not strongly connected. You're the one in your code that has to actually get them connected together. Increment index, and while, right, there you go. Okay, so nothing else at this point really interesting to do with these other than just to introduce this idea. You know, what you can do is you can create yourself a database table of all the parts in your inventory, their names, their cost, anything else you need to keep track. You can do the same thing with like an address list, people's names, their addresses, how old they are, their favorite color, right? Each one of these would be its own separate parallel array. The arrays then should all be the same length, right? Because you're going to have as many items as one as the other. Right. So there's a basic idea. Again, remember the problem that you got is that arrays are typically declared of a particular type. They're numeric or they're strings, something, at least in our pseudocode language. Usually in actual programming languages, they can be floating point or Boolean or something like that. But they all have to be, every element has to be the same type. Of course, now, as soon as I say that, turns out with lists in Python, they don't all have to be the same type, but Python's kind of plays pretty loose with some of the common rules of programming languages. So anyway, there's the idea of parallel arrays.